My greatest x minus y is actually 11. Is that what you have? If you have, give yourself a take. Because there are no answers provided, right? Yeah. Okay, then the smallest x cubed plus y square, I have -1. What do you have? So check if you have something smaller, check with me. Maybe I made a mistake. Part 3, the least value of x over y, I have it as -6. If you have something smaller than me, let me know. Maybe I made a mistake. Can? Then let's move on. Next one, simplify. So simplify 3 times 5x minus 4 plus 2x plus 6. Okay, simple. It turns out it is just 17x. And now they say hence. Always highlight the word hence. Hence, solve the inequality. Then you identify that the left hand side of the inequality, okay, your 3 times of 5x minus 4 plus 2 times of x plus 6, this is exactly the same as what they told you to simplify. Which means that your answer 17x is greater than or equal to -51. So you do the substitution. 17x greater than or equal to -51. And just do a division. Since we are dividing by positive 17. Dividing by a positive number, the inequality sign doesn't change. But if you are dividing by a negative number, then the inequality sign will change. So representing it on the number line looks like this. Greater than or equal to -3, we must circle and color the -3 spots. And in part B, state the smallest integer such that it is greater than or equal to -51. The smallest integer lies on this arrow, and the smallest value is -3, and that's the answer. Now in the event that this is a hollow circle, means you didn't circle it, then the smallest value will then be -2, smallest integer. But now it is circled, so we include the value of -3. Okay, then oh, I didn't do question 3. Okay, so part B, it is -3. And question 3, write down the inequality represented. It is x in the middle. X is greater than -2. We cannot include -2 because they did not color it. At the same time, it is less than or equal to 5. So this is the next answer. And now we move on to triangles and polygons. Information given, regular sides of a regular polygon. So for a regular polygon, it means that all the sides are the same. They have the same length, and the angles, they're all the same. So they further give us that angle CAB 18 degrees, find angle ABC. So what we see over there is an isosceles triangle, right? With one of the two common angles as 18 degrees. So just take away, and the reason still must be stated, angle sum of isosceles triangle. So this is my shortcut of combining two reasons. The first reason is our angle sum of triangle. That's where we get 180 from. The second portion, base angles of isosceles triangle. That is why we have a 2 times 18. So this is my way of combining two reasons into one. So we get 144 degrees, and that will be one of the internal angles of the regular polygon. So then find the number of sides of the polygon. Standard approach, let the number of sides be n. So one of the interior angle will be 144. And how do we find that value? It is given by 180 times of n minus 2. So this is a formula. This will be the total angles in the polygon, total. Then we divide it by n because there are n sides. And that gives us 144. Okay, recap of why it is 180 times n minus 2. Because for a 4-sided figure, 4 sides, you can divide it into 2 triangles. So the total angle will be 2 times of 180. So 4 sides minus 2 to get 2 triangles times 180. That will be the total angles inside. if I have a 5-sided figure for 5, any 5-sided, not regular, doesn't matter. You can divide it into 3 triangles. So 5 sides minus 2, you get 3 triangles, multiply by 180 degrees. 1, 2, 3 triangles. Total add up to be 180 degrees. So if it is n sides, we will be able to get n minus 2 triangles multiplied by 180 degrees. So this is the reason why our formula looks like such. Now that you have formed the equation, it is just a matter of doing your algebra, your manipulation, and solving. So put over 1, multiply. Okay, or you can simply multiply by n on both sides. Solve, you get n equals to 10. It is a 10-sided figure. A 10-sided figure, a regular 10-sided polygon, will have one of its angle as 144 degrees. So finally find the angle ACD. ACD. The angle ACD is made out of the interior angle of the polygon, take away 18 degrees. Simple as that. So you get 126 degrees. No reason for that. It is just a combination of 2 angles. So the next one, find the unknown angles P, Q, and R. Different ways of doing it. All I need you to do is check the final answer. P, Q, R. If your answers are correct, chances are you know how to do it correctly. The next thing I need is for you to write reasons. So you could be using alternate angles, parallel lines for some of your working also. Okay, so in my own working, I only needed to use corresponding and interior angles. You can choose to use alternate angles. So important thing, make sure our 3 values are the same. Need me to go through anything else on this page? Okay, then let's move on to expansion. 7a, b, c, and d. Nothing much to talk about. Check your final answer. Okay, let's start with A, B, and C first. Okay, so answer for A, answer for B, and answer for C. Do you need me to go through anything? Jermaine, do you get them correct? Do you know which question this is? We're on page 6. Let's start with the first one. Does anybody need me to go through part A? Part A? Ninghuan, need? Part B? Need? Part B. Okay, let me check. Because I also don't know whether I made any mistakes or not. Okay, now this is a case of A minus B. And we square the whole thing. So the formula for A minus B square, A minus B, when you square it, you get A squared minus 2AB plus B squared. So what is our A over here? Our A is 2. So we square the 2, we get 4. Okay, first part, no problem. The first term is correct, definitely. Now we have to subtract 2 times of, let me put this aside and I do it for you here. It's 10. Okay, A square, so 2 square, minus 2 times of A times B. What is our B value? 5 over 6x. A square minus 2AB plus B square. What is our B again? It is 5 over 6x. And I need to square it. So let's simplify. We get 4 minus, okay, so here we can simplify 2 and 6, this becomes 3. So negative 2 times 5, we have negative 10. So minus 10 over denominator is 3x. Final term plus 5 square, you get 25 over 6x square, 36x square. Minus 10 over 3x plus 25 over 36x square. Yep, correct. Ishan, okay? Can I just check? Did anybody do this without formula? That means you tried to do a rainbow method. Like this, 2 minus 5 over 6x squared. We should try to do this. 2 minus 5 over 6x. Then you multiply by another 2 minus 5 over 6x. And then you did the multiply, you get 4. Then minus 5 over 3x. And minus 5 over 3x. Finally, you have a plus 25 over 36x squared. This works also, isn't it? But it's just that more steps off. You see, 4, then you minus 2 of the same things. 2 of the same things, 2ab. Okay, so 2 minus 10 over 3x. Then you plus 25 over 36x squared. It's the same, but takes you a bit more time. And more room for careless mistakes, the more steps you have. So my recommendation, just memorize the formula. Okay, so next one, part C. Anybody needs to go through part C? No need, Jiaxin, okay? Then the final one, part D. This is our final answer. So just expand. Just be very careful. This is sec 1 work. Any issues with part D? Zheng Jie, okay? Just furiously writing with your green pen. What does that mean? Next page, factorizing. 4 terms. 1, 2, 3, 4. 4 terms, pair them up. Let's see if there are common terms, common factors in the first 2 terms. Let's consider the first 2 terms. Okay, there is a q. Factorize out the q. Left with p plus 2x. Consider the next 2 terms. So notice that I also enclose the negative sign for the 4px. So for the last 2 terms, we need to identify the common factors. So definitely we have a 4, we have x. The question is, do we factorize out the negative sign? It appears in both of them. Yes, we should factorize it out, provided what is remaining is the same factor that is left in the previous 2 terms. Okay, so by factorizing out negative 4x, I get the same p plus 2x. If I had factorized out positive, then this would have been negative and negative, which is different. Then cannot factorize, so you need to factorize out negative. Okay, so switch it back. This is what we have. So given that p plus 2x is a common factor, put it here. What is left is q minus 4x. q minus 4x. After you factorize out the common factor of p plus 2x. Over here. In part B. Okay, now part B, when you are supposed to factorize this 6y squared minus 7y minus 5, 3 terms only. So 3 terms, you use the box method over here. So I think I drew nine boxes, is it? Multiply. Okay, we require a 6y squared. And we need a negative 5 on this side. So your job is to identify the blanks over here in order to get a factorized form. And I actually hinted to you that actually there is a way for you to use your calculator for that. Okay, let's see what happens if we key into our calculator 6y squared minus 7y minus 5. So if you are using this model, press the menu setup, go down to equation. So that's option number 5. We go to polynomial. Polynomial will be a term that you will see in Sec 3 A Max. So polynomial, option number 2, the degree, that is the highest power. The highest power that we have is 2, 6y squared. Now we're going to insert the coefficients. The first coefficient is 6. In our calculator it says x squared, but it is just a variable. In our question it is y squared. So just pretend all your x is y, all the y is x. So we have the 6 as the first one. Next we have negative 7. And finally we have negative 5 as the final term. So when you press it, okay, observe what the calculator tells you. It tells you 5 over 3. Okay, look at the factorized form. Can you see a 5 over 3 somewhere? Something that looks like 5 over 3? If you do, you pause first. I'm going to press equal again and you see what happens. Or how this? Before I press equal, can you guess what the calculator will show me? Before I press equal, based on this 5 over 3, I see a 5 here, I see a 3 here, and I see a minus sign. Based on pattern, what do you think the calculator will tell me for this part? What do you think, Sean? How much? 1 over 2, Okay, so Sean is suggesting that he thinks the calculator will show 1 over 2. What do you think? Will it show 1 over 2? Because if you can get this correct, it means you know how to use the calculator for every single quadratic factorization. Very powerful. Don't need to do the box. So what is it? Is it half? Is it 1 over 2? Negative half? What do you think? You got a different answer already. Negative half. Should we change the sign? Let's see. Equal. Negative half. That means Aloysius knows how to use the calculator already. For every single type of quadratic factorization, can use calculator. Straight away get answer. Which means when I key in all this, right, what will be going through my mind is in my calculator it gives me 5 over 3. I just put it down first. Okay, calculator says 5 over 3. Calculator says negative half. So in my answer, bracket, which is it? 3y. Then because it is a positive number over here, right, so minus 5. Okay, then the denominator goes to the y term, 2y, because it is negative, plus 1. This is a shortcut lah. So how does it work? You will learn more about it actually in Sec 3, when we teach you how to solve this. Is this Sec 3? Yeah, I think it's Sec 3. Okay, so for now, if you don't know what's happening over here, don't worry. You can still use your box to help you solve it. So your 6y squared and your negative, is it negative 5? Yeah, negative 5. It will still work. Okay, next one. Part 2. Is it part 2? B part 2. Hence, factorize. 6m minus 1 squared minus 7m minus 1 minus 5. These two questions, they're related. When there is a hence, you must use what was previously found. Okay, so I'll do this on the paper itself. So this was factorized to give us 3y minus 5 multiplied by 2y plus 1. So look at the similarities between these two questions. I've got a 6, 6. I've got a y square over here, but this is a m minus 1 square. I've got a minus 7, same thing, minus 7. I've got a y instead. This is m minus 1. Then I've got a minus 5 and a minus 5. What this suggests to us is that they are telling you, actually they're making it very clear already, tell you to let y equals to m minus 1. Right? As long as you change all the y in part 1 to become m minus 1, then it becomes my part 2 question. So let y be equals to n minus 1. And now, all these y's, they become n minus 1. So what will it then look like? This. 6y squared, y becomes n minus 1, minus 7y, y becomes n minus 1, then minus 5. And we're going to make use of our result in part 1. It says when we factorize, we get 3y. But instead of writing 3y, we write 3 and minus 1. Then copy down to minus 5. Multiply by 2 times of y, which has been changed to n minus 1. Then plus 1. And then you simplify within these two square brackets. Expand and simplify, and this is our factorized form. Okay, 3m minus 8, 2m minus 1. Oh. Okay, next one is the part C, 24a cubed y minus 6ay cubed. Don't worry, all this will be uploaded onto Google Classroom. Important thing is that you understand what's happening in class. The copying can come at your own time later on. Okay, so next one, part C. 24a cubed y minus 6ay cubed. Common factors, okay, number-wise, we have 6. Letters, A. Y, we also have y. And now we are left with, for the first term, 4a squared. The moment you write 4a squared, you must be very sensitive already. 4a squared can be written as 2a, the entire thing squared. Because 2 squared is 4. Then we are, on the other side, we have minus y squared. Do you notice something? This can be written as 6ay 2a squared minus y squared. This is our x squared minus y squared, or a squared minus b squared. So within our square bracket, we can further factorize 2a plus y, 2a minus y. And we notice that the square bracket, useless. Take it away. And this is our final answer. So it is not as simple as just factorizing out the 6ay. You cannot just stop there. Within the curved bracket, you have to recognize that it is a perfect square minus another perfect square. Be very sensitive to the perfect squares. 4, 9, 16, 25, so on and so forth. So part C done. Then now question 1a, special products. X squared minus y is the form of x. This is the same as x squared minus 3 squared. So a squared minus b squared, you have a plus b, a minus b. You have to memorize this. Very familiar with it. When you see x squared minus 3 squared, straight away write it down. That's the factorized form. And then in part B, hence, find two other factors. So hence means you have to use the previous part. So what has 1591 got to do with x squared minus 9? What do they have in common? So this portion, you should notice that the minus 9 and the 1591, if you were to add the 9 to 1591, you get a very nice number, 16,600. So instead of taking away a 9, you put it back. You get 1,600. So if we rewrite the 1591 to become 1,600 minus 9, which is true, it is true. If we rewrite it as such, we end up with 40 square minus 3 square. Because 1600 is 40 square. So like I said, sensitive to number 16 as well. See, the number 16. So square root 16, 1600, you get 40. So 40 square minus 3 square. Special product, it becomes 40 plus 3, 40 minus 3. And then we get 43 times 37. And these are the other two factors of 1591. Because factors are just something multiplied by another number. Then for question 2, so u square minus v square, they tell us that it is 28. Same. And we recognize that u square minus v square, u plus v, u minus v. Do the substitution. They tell us that u minus v is equal to 8. And so u plus v must be 28 over 8. This is just 7 over 2. Okay, don't be scared by this question. It's just a substitution after you know the special product. And we'll end off here today.